Stop memorizing the formulas, because today I'm going to show you how Riemann sums are actually built. So imagine we're trying to find the Riemann sum of our graph f of x from interval a to b. So we're going to divide the interval into smaller subintervals. For example, let's divide it into 3 for now. So the length of each subinterval will be given by b minus a over 3. If I keep increasing the number of intervals, my general formula of the length of each subinterval will be given by b minus a over n, which is my delta x. So that becomes my breadth. And to find the length of, let's say, the right Riemann sum, I'm going to create the rectangles from the right endpoint of that subinterval. So as we know, the area of rectangle is given by length times breadth. So for the right Riemann sum, I'm going to find the right length of that subinterval and multiply it by the width. So the length of first rectangle will be given by f of a plus delta x, and for the second one, it'll be f of a plus 2 delta x. So I can generalize the formula and write it as f of a plus I delta x, where I goes from 1 till n. And I'll multiply this by my delta x function, which is my breadth. And since I'm adding all of the areas of these rectangles, I'm going to add a summation sign where I goes from 1 to n. So for my left Riemann sum, I'm going to start drawing my rectangles from the left side of my subintervals, which are going to look something like this. The width of all of my subintervals is going to remain the same, which will be delta x. And to find the length, I can generalize my formula as f of a plus I minus 1 delta x, as I'm trying to find all the lengths from the left side of my subinterval. The length of the first one will be given by f of a, the second one will be given by f of a plus delta x, and so on, where my I goes from 1 to n. So now that I've generalized my length formula, I need to multiply it by my width to find the area of each rectangle. And since I'm adding all of them, I'm going to add a summation sign where my I goes from 1 to n. Similarly, for the midpoint Riemann sum, I'm going to take the length as my midpoint, and width still remains the delta x. So to generalize this formula, I'm going to write the length as f of a plus I minus half delta x, which is my length, and I'll multiply it by my delta x to find the area of each rectangle. To add all the areas, I'll add another summation sign where my I goes from 1 to n.